So let's calculate a unit normal vector given a starting position vector. Well, we have that n of t is t prime divided by the magnitude of t prime. So clearly to get n, we need to get t. And remember, to get t, we have to get r prime. So we're going to be doing several steps along the way. So r prime of t is just going to be I plus t j. So the magnitude of r prime is 1 plus t squared. It's square root of 1 plus t squared. So that tells me that t of t is 1 over the square root of 1 plus t squared I plus t over the square root of 1 plus t squared j. And that's our first piece. So the next thing we need to do is we need to get t prime. So t prime of t. Now, there's a couple of different ways to do this. This you could think of as 1 plus t squared to the negative 1/2. So that would be negative 1/2, 1 plus t squared to the negative 3/2. And then chain rule tells us we need to take the derivative of that, 2ti. And that would be okay for, and we're going to simplify this, but that would be okay for that one. For this one, since I have t's on tops and bottoms, maybe I'll use the quotient rule. So the way the quotient rule goes is it's low times the derivative of the high. So that's 1 plus t squared to the 1/2 times the derivative of this, which is just 1, minus the high times the derivative of the low. So that's t times 1/2, 1 plus t squared to the negative 1/2. Again, chain rule here gets me 2t all over low times low. So then that's just 1 plus t squared. And that's j. So let's do a little bit of simplification here. All right, 2t in that, so that becomes negative t over the square root, or over 1 plus t squared to the 3/2 I. That wasn't so bad. Now let's take a look at this. So if I multiply top and bottom by 1 plus t squared to the 1/2, what I get is 1 plus t squared minus, then I have to calculate this out. So the 1/2 and the 2 cancel, and the t becomes t squared. So that's t squared. And if I multiply by the square root of 1 plus t squared. So that actually cancels that one out. And then on bottom, I have 1 plus t squared to the 3/2 j. And I can simplify that then by saying negative t over 1 plus t squared to the 3/2 I plus 1 over 1 plus t squared to the 3/2 j. Now, I know that was a lot of work to simplify, but this is going to pay off because when we take the magnitude here, we really want this to be as simple as possible. So then when we get the magnitude, let's go up here to get the magnitude. We have this squared. So since that's to the 3/2, that's just going to go away. So it's going to be t squared over 1 plus t squared cubed plus 1 over 1 plus t squared cubed square root, which is 1 plus t squared over 1 plus t squared cubed, which then we can cancel to be 1 over 1 plus t squared squared, which we can then reduce to just be 1 over 1 plus t squared. Well, that's kind of nice. So then when we take t prime divided by the magnitude of t prime, so that's n. So dividing by the magnitude is like multiplying by the reciprocal, right? So I can take this piece, I can say negative t 1 plus t squared over 1 plus t squared to the 3 halves I plus 1 plus t squared or 1 plus t squared to the 3 halves j. And then I can cancel these 1 plus t squareds, or at least reduce it. Negative t over the square root of 1 plus t squared I plus 1 over the square root 1 plus t squared j. And if you took this and dotted it with t, what you get on top is negative t plus positive t over 1 plus negative t plus positive t on top over 1 plus t squared on bottom, but the top becomes 0. So we see that n and t are in fact orthogonal vectors. So then what we would want to do at this point is, now we have this, let's find n at 2. So n at 2 is negative 2 over the square root of 5i plus 1 over the square root of 5j. And yeah, computing unit normal vectors is pretty tough. So practice makes perfect here.